Welcome to qnawire.
For this problem, we need to calculate some derivatives at some given points, and we are only given the graph for the function f of s. So what we are going to do is to calculate the slope of the tangent function at each of these points, and because that's the definition of a derivative in a given point. So what we are going to do in this first point, we need to calculate the derivative of the function in the position -3. So we see that -3 is in here. And a tangent line, we just draw a tangent line and we just can see drawing a tangent line. So with this tangent line, we can see that we are given 2 points. The first point is in -3, and this corresponds to a height or y component of approximately minus 1.9, which is this that I'm going to mark with red color. And the other point is this one here. So we can see that this point is -1 in the x component and approximately -2.3. So with 2 points, we know that knowing 2 points of a function or of in this case the tangent line, we can know the slope by following this formula. The slope is equal to the final point that we're going to call it as, I put it in here, as f of s2 minus f of s1 over s2 minus s1. In this case, we know that this first corresponds to s1, this to s2, and this to the evaluation of the function f of s1, and this f of s2. So substituting this in here, we will have minus 2.3 minus 1.9 over -1 minus -3. So this gives us a value of -0.2. So approximately the derivative of the function at the point -3 is equal to -0.2. So this is the first derivative that we just have calculated. Now we want the derivative at the point -2. So again, we see the pointer is in here, making a pointer, and we just draw a tangent line to that point. We can see that drawing a tangent line to that point will produce an horizontal line. So this is very straightforward. We know that the slope of an horizontal line is 0. So we can just simply say that the derivative of the function in the point -2 is just 0 because it is equal to the the slope of the tangent function and the slope of the tangent function in this case is equal to 0. So we will have that. Now, for -1, we see that this is in here, so we're going to just draw there. And we're going to try to draw a very straight line. Sorry. Try again. Here. Let's try again. A better one. Okay, just let's gonna leave it like there. No, it's just it needs to be like a tangent line. So we're gonna try better. Okay, that's better. So we have 2 points. The first one, we can see from the graph, I'm gonna mark it in red, is approximately the y component is approximately minus 1.5, and the other one, the other point, is that here. You could see that this point in here, we're gonna mark it in here, and this point is in the x. The x component should be 0.5, and the y component is just -1. So from here, we just again can obtain the slope. So the slope in this case, we just know using this formula, and f of s2 is this in here, so we'll put it in here, minus f of s1 over x2 minus 1. So this gives us a value of values of 1. Oh no, sorry. This gives us a value of yes, it gives us values of 1. And so that we conclude that from here, we conclude that the derivative of this function in x equal to -1 is equal to 1. Now for f, for the derivative of the function at 0, 0 is at here, and we just draw a tangent line, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. So we have the point, the first point is 0, 0, and the second point we could see that is, let's try it better because it's not like a tangent line. It should be more, okay, okay, so get starting here. We can see that if we're starting here, passing here, it's a better Okay, so in this case, we have 0, 0 is the first point, and the second point is approximately in here is minus 1 in the x part and minus 2 in the y part. So the slope is simply, again, we use the formula minus 2 minus 0 in this case, and minus 1 minus 0. So this gives us a slope of 2. So we conclude that the derivative of the function at 0 is equal to 2. Yes. Now, for the following value, for the derivative at the value x equal to 1, it's in here the point. So we're gonna try to draw our best tangent line. So let me see, we're gonna try starting here as in the point. So, okay, so we have the point 1, 1, and in here 1. We're gonna take these 2 points. So this in here is 1, and the y part is the y component is 1.5. The second point is a little higher. It's a little higher of 0.5. So we're gonna say that it's 0.6. And the x bar, of course, it is in the 0. So taking the slope, we know that again this is 0.6 minus 1.5 over 0 minus 1. This gives us a slope of 0.9. So approximately the derivative at the point 1 is 0.9. The next derivative is at f equals 2. So at s equal 2, as in the case of x minus 2, we will have an horizontal tangent line. So we just conclude that this is equal to 0, the derivative at the point x equal to 2. Now, at f, the derivative at x equal 3, we will have this in here, and we just try to draw our best tangent line. So, like this. So, we are going to take these 2 points, one in here and one in here. So, we have the point 3, 1.9 approximately, and the second point, it's 1 in the x component, and for the y part is approximately 2.3. We're going to say that is 2.3. So taking the slope of this is going to be 2.3 minus 1.9 over 1 minus 3. So in here we will have a value of minus 0.2. And this gives us approximately a value for the derivative at the point 3 of minus 0.2. Now, to graph this function, the f prime function, or the derivative of the function f of s, we just need to first we are gonna like just copy all the information in here, the value of x and the value of f of s, the derivative of s that we just have obtained. So for x, we have the values minus 3, minus 2, minus 1, 0, 1, 2, and 3. And for the f2, we just have that. For the first one, we obtain 0.2, 4 minus 2, 0, 4 minus 1, 1. For 0, we obtain 2. For 1, 0.9. And for 2, 0. And for 3, again, 0 minus 0.2. So we're just gonna put all this in the graph, and we just sketch the graph that we can obtain from just so for minus 3, that is in here, minus 3, the value of the function is minus 0.2. So it is very like approximately in there. We're gonna put it in a red color to differentiate. Now for minus 2, that is in here, minus 2, we have 0. So it's in here in the x-axis. For minus 1, that is in here, minus 1, it's 1. That is in here. For 0, it's 2. For 1 is 0.9. We are gonna like, well, it's kind of in here. For 2, it's 0. Again, 0 in here. And for 3 is minus 2. So we have attained almost a very symmetric function. So if we just unify all these points, we obtain that this is something of this form. We cannot be sure exactly how the function is, but it's going to be some kind of this form. So this is the graph of the function of the derivative of the function f of x that we start with.